I first saw the structure on a cold evening in November 2023, walking along Obukova Street in St. Petersburg, where the official record places the construction of the Nikolaevsky Foundry Annex in 1884. It seemed unremarkable at first, a squat brick hall attributed to engineer V.V. Kolchak, listed simply as auxiliary storage for metallurgical components. I had come to verify routine renovation documents from 1927, nothing more. But an 1885 construction photograph in the municipal archive caught my attention. In the background, half erased by exposure decay, stood a cylindrical granite shaft with joints too fine for 19th century tooling, and beside it the faint outline of what looked like a hydraulic access chamber. When I visited the site, measuring the northern wall almost absent-mindedly, I found the symmetry exact to the millimetre. More precise than any workshop of the 1880s, something here was wrong, quietly, persistently wrong. I closed my notebook that night, realizing this would not be simple research. The municipal records describe the Nikolaevsky Foundry Annex, completed in 1884, as a minor structure in the Vyborgsky district, barely worth mention. Industrial architect Andrei Dmitrievich Sokolov stands as its official designer, though his surviving portfolio reveals no particular innovation. The annex was supposedly built of standard brick atop rubble stone, serving as storage for raw metal stock awaiting processing in the main foundry building across the courtyard. Yet the first archival object I encountered, a faded 1885 gelatin silver print stored in folder 47B of the municipal construction records, contradicted this simplicity entirely. Captioned, "North elevation under construction," the photograph revealed a foundation of precision-cut granite blocks, each nearly seamless where they met. Measuring against a scale figure in the frame, I estimated some blocks weighed over 5 tons, far beyond what the annex's documented cranes could handle. The 1884 shop ledger credits the facility with 2 pulley cranes capable of only 1.3 tons maximum load. I returned to examine the photograph under magnification. The granite joints showed tolerances I estimated at less than 2 millimeters, a precision that would challenge modern stone-cutting equipment. For context, typical 19th century Russian masonry work left gaps of 5 to 10 millimeters filled with mortar. These blocks required almost no mortar at all. Inside the annex today, accessed through a municipal permit process that took 3 months, the granite still sits perfectly flush. I ran my fingers along the joints, feeling for the characteristic roughness of chisel work. Nothing. The surfaces transitioned seamlessly as though the stone had been cut with water jets or laser-guided saws, technologies that would not exist for another century. Even with advanced modern saws, matching this precision in granite remains costly and time-consuming. Granite is among the hardest building stones, rated 627 on the Mohs scale. Achieving such fine tolerances requires diamond-tipped blades, computer-guided cutting systems, and extensive finishing work. For a minor auxiliary annex built to store metal ingots, such work borders on excessive, bordering on inexplicable. Reviewing the 1927 renovation log, filed under Structural Modifications, Industrial District, I found a note dated April 17th, sealed lower access corridor discovered during floor replacement, bricked over per supervisor instruction. The log offered no plan, no measurement, no architectural drawing. Just an acknowledgement of a hidden void beneath the structure, treated as an inconvenience rather than a curiosity. I visited the site again the next day, this time with a measuring tape and digital level. Tracing my hand along the granite joints in the northern wall, I worked methodically from corner to corner. The transitions were impossibly smooth, lacking the chisel marks, the percussion fractures, the subtle irregularities characteristic of hand-tooled stone from any period before the late 20th century. Symmetry, scale, material, Each element contradicted the building's stated purpose and documented construction methods. I should have filed the anomaly away as an interesting but minor historical footnote. Instead, I found myself returning to the archive that evening, enlarging the 1885 photograph repeatedly on the lightbox, isolating the outline of a cylindrical shaft visible behind the annex's eastern wall. It appeared older than the structure itself, a relic absorbed into later construction, its purpose already forgotten when Sokolov drew his plans. By midnight, sitting alone in my apartment with the photograph printout spread across my desk, I added the first quiet question to my research journal. Why would a routine industrial annex require foundations built with a precision its architects could not achieve? Archive plate 17B, dated March 1885. It was labelled Southern Wall Scaffolding, an unremarkable caption that should have depicted workers and wooden frames. But when I examined the image closely, the shadow angling across the snow-covered ground did not match any part of the existing annex structure. Shadows don't lie about geometry. They record the exact position of the sun relative to objects at a specific moment in time. I returned to the site in late November with a digital inclinometer and a solar position calculator on my phone, standing roughly where the photographer would have been positioned. I waited for the sun to reach approximately the same angle it would have occupied in mid-March at the latitude of St. Petersburg. The mathematical precision of celestial mechanics allowed me to recreate the lighting conditions with reasonable accuracy. The discrepancy persisted. The shadow in the photograph belonged to something circular, massive, no longer present at the site. Its diameter, approximated against the scale of workers visible in the photograph and cross-referenced with known heights of scaffolding from the period, suggested a structure at least 4 meters across, possibly larger. The 1885 Engineering Journal of Sokolov, preserved in remarkably good condition in the State Archive, mentioned an object delivered several months before the photograph was taken. Large bell form received by barge at dawn, February 14. Unusually heavy, required hydraulic reinforcement under east platform. Delivery crew refused standard rates, demanded triple wage for handling. Bell form, hydraulic bracing. Yet no bell casting is recorded in the foundry's operational history, and the facility's documented purpose involved smelting raw iron and bronze for railroad components, not precision casting of large musical instruments. Later that night, working at home with high-resolution scans of plate 17B, I enlarged the image at maximum contrast using photo analysis software. Behind the stacked timbers in the mid-ground, partially obscured by construction debris, I noticed a faint metallic curvature. The surface showed none of the hammered texture typical of forged metal plates from the period. Instead, it possessed an unsettling smoothness that implied machine tooling, lathing or grinding work far beyond the capabilities of the 1885 Russian industrial equipment. I cross-referenced this observation with renovation records from multiple decades. Only the 1927 log referenced the sealed lower corridor, but a terse addendum, written in different handwriting and apparently added later, caught my attention. Lower chamber walls smooth, no fittings, no apparent purpose for space. Recommend permanent sealing. Smooth, unworked walls beneath a rough 19th century workshop. The contrast was architecturally nonsensical. Outside the annex, on the eastern perimeter wall, I discovered a bricked archway during my third site visit. The arch was perfectly semicircular, not approximately round, but geometrically precise. I measured it with a radius template. Its curvature matched the radius I had calculated from the photograph's shadow to within centimeters. Mortar analysis, conducted informally by a colleague in material science, suggested the sealing took place sometime in the 1930s, long after the annex ceased industrial operations following the consolidation of foundry work in 1919. Someone had gone to considerable effort to brick over this entrance decades after the building's abandonment. This arch became my first recurring motif, the impossible symmetry that appeared again and again as I deepened my investigation. I wrote one quiet note beneath my copy of Plate 17B that night. A circular object once stood here, large, machined, carefully positioned. Why was it removed, and why was every trace of its presence erased so thoroughly from the historical record? The meticulous 1880s city planning records, generally comprehensive for St. Petersburg's rapid industrial expansion, contain surprisingly little about the Nikolaevsky Foundry Annex, an odd omission for a structure connected to rail transport infrastructure. The Ministry of Rail Transport mandated strict documentation due to the catastrophic risks of heavy machinery failure in populated areas. Boiler explosions, crane collapses, and structural failures had killed dozens of workers in the previous decade. Yet the annex appears only sporadically in these records, often without the foundation load calculations, crane specifications, or materials inventories that regulations required. I examined an 1884 construction map prepared by surveyor P.M. Lebedev, whose work on other industrial sites showed meticulous attention to detail. Where the annex stands today, the map shows an empty lot designated for future development, but beside it, approximately 8 meters east of the eventual foundation, lies a hand-drawn circular mark rendered in faded brown ink. The margin note, barely legible, reads, "Stone base existing, purpose unknown. Recommend survey before construction." In later map revisions from 1886, held in a different archive folder, this circle disappears entirely, not merely omitted, but deliberately erased. When I held the newer map up to the light, I could see the faint impression of the circle beneath the fresh ink, suggesting someone had traced over the original to obscure it. A factory inventory ledger from 1886, discovered misfiled in records related to a different facility, lists 2 hydraulic pistons, German manufacture, and a rotational lifting frame with counterweight system, specialized equipment worth noting. None of these items appear in surviving photographs of the annex's interior, nor do they match any known equipment installed in Russian foundries of the period. Hydraulic lifting systems existed but remained expensive and rare, typically reserved for naval dockyards or major metropolitan construction projects. The pistons alone would have cost more than the entire documented construction budget for the annex. In a drawer of uncatalogued materials, I found a photograph that had been torn and later crudely repaired with tape. It was labelled Test Rig, March 1886 in pencil on the reverse. The image depicted a large machined metal ring resting on a timber cradle. The ring's surface appeared smooth, possibly polished. The supporting timbers, which I could identify as standard railroad ties based on their dimensions, suggested a diameter roughly consistent with the circular shadow in Plate 17B, approximately 4 meters. The sealed granite arch at the annex's east wall, which I had measured during multiple visits, mirrors that radius precisely. The arch's interior surface, visible where mortar had crumbled away, showed the same impossible smoothness I had observed in the foundation blocks. Official municipal history said the annex was built in 1884 as a simple auxiliary structure, but its foundations, the quality and precision of its materials, and the hidden geometry beneath suggested something older, something whose original purpose had been repurposed or deliberately obscured. I spent an evening comparing the construction timeline with material costs. The documented budget could not have covered the granite work I had observed. Not even close. Either someone had dramatically understated the costs in official records, or the granite had been salvaged from an earlier structure, a structure that itself would have required extraordinary resources to build. I wrote a question in the margin of my notebook, a question that would guide the next phase of my investigation. If the annex is younger than the stone beneath it, what was here before and who possessed the capability to build it? The first explicit reference to a giant bell surfaced in the St. Petersburg Engineering Review, June 1887 edition, in a brief article buried on page 47. The author, metallurgist Ilya Tretyakov, describes examining a massive bronze bell of unusual construction that had been transported through the Kanovinsky freight yard in Nizhny Novgorod. No weight is given, no origin specified, only a troubling detail that Tretyakov emphasized in italics. Surface appears honed, not cast, visible seams entirely absent. A honed bell. The observation troubled me. Bells, by their fundamental nature, are cast objects, molten bronze poured into molds, allowed to cool, then minimally finished. The honing process, if applied at all, to a bell's exterior would be purely cosmetic and would risk ruining the carefully calculated thickness variations that produce proper tone quality. Yet Tretyakov, a respected metallurgist who had published 17 papers on bronze composition, insisted on the observation. He was not a man prone to careless mistakes. The photograph I found next, catalogued as Plate 32F in a different archive collection, showed a bell suspended from a temporary wooden gantry in the Gostiny Dvor courtyard in central St. Petersburg. The image was dated August 1888. The bell's surface gleamed with an unnatural smoothness in the camera's flash, devoid of the typical flow lines, surface pitting, and minor irregularities characteristic of cast bronze. Measuring against the men standing beside it per scale, I estimated their heights at 170–175 centimeters. Based on period averages, the bell's diameter reached approximately 4.1 meters. The measurement matched the shadow at the annex almost exactly. But St. Petersburg possessed no facility capable of producing or machining a bell of that size in the 1880s. I verified this by reviewing the capacity records of every foundry, shipyard, and heavy industrial facility in the city. The largest recorded bell casting project in Russian history, the Tsar Bell at the Moscow Kremlin, weighed over 200 tons, but was cast in 1795 using techniques fundamentally different from anything suggested by Tretyakov's description. It was cast in place, in a pit, and never successfully mounted or rung. No facility in the late 19th century attempted anything comparable. The transportation notes accompanying Plate 32F, written on the reverse in clerical script, mention a reinforced timber subframe with hydraulic dampers to prevent damage during movement. The term hydraulic damper in 1888 would have been experimental at best, a concept discussed in engineering journals but rarely implemented. Yet here it appeared as a routine notation, as though such technology were commonplace. The bell's provenance is marked only as Tartarian origin, a term I found repeated in 3 separate documents, always in footnotes, and always crossed out in later revisions or subsequent copies. Tartary was a vague geographical term used in earlier centuries to describe parts of Central Asia, but by the 1880s it had fallen out of official use. Its appearance in these contexts seemed deliberately archaic. I compared the bell's proportions in Plate 32F with the curvature visible in Plate 17B from the annex construction site. Using overlay analysis and geometric scaling, the match was precise, not approximate, but identical within the margins of photographic distortion. Another archival reference emerged from an unexpected source, a brief mention in the Warsaw Courier, October 1890. A journalist covering freight transport reported seeing a colossal bell, clearly of great age, being freighted northward on a specially reinforced wagon, escorted by military engineers. The journalist noted that its movement caused perceptible vibrations in the cobblestones as it passed through the street, a detail suggesting tremendous mass. Why were such bells being transported through the Russian Empire during the late 19th century? Why do the official industrial records, usually meticulous about large-scale metalwork, never acknowledge their manufacture? And if they were not manufactured in that period, where did they come from? I added another quiet note to my journal that evening. If these bells were not cast in the 19th century, then they must have been transported from older sites now forgotten, deliberately omitted from records, or systematically erased from historical memory. In the archives of the Moscow Polytechnic Institute, housed in a basement room that smelled of old paper and machine oil, I found a miscategorized box labeled Miskia Hydraulics, 1875-1882. Inside, beneath layers of unrelated mechanical drawings, lay a set of blueprints dated April 1879, authored by engineer Sergei Ignatov. The plans depicted an elaborate hydraulic cradle, a circular platform supported by 12 adjustable pistons, arranged in a radial pattern, clearly designed to support a heavy cylindrical object while allowing for precise leveling and vibration control. The margin note, written in Ignatov's precise hand, read, "Load range 90-110 metric tons. For object transport under tight vibration constraints, pressure distribution, critical, any imbalance, risks, structural resonance." No known object in Russia in 1879 required transport under such extraordinary mass and precision. For comparison, the largest artillery pieces of the era weighed approximately 50 tons. The heaviest industrial boilers topped out around 60 tons. What object could weigh 110 tons and simultaneously require protection from vibration? The blueprint scale, which I carefully measured against the standard measurement bars printed on the page, indicated a platform diameter of 4.2 meters. The match with previous measurements was once again exact. The hydraulic system detailed in Ignatov's diagrams was decades ahead of its time. I consulted with a colleague who specializes in the history of mechanical engineering. He confirmed that the first practical hydraulic suspension systems with pressure distribution comparable to Ignatov's design emerged in the early 20th century, primarily for naval applications. Yet here, in 1879, Ignatov had clearly outlined a 12-piston pressure distribution mechanism with individual flow regulators, backup pressure chambers, and a central monitoring gauge, concepts that resembled modern load management systems. One journal page was tucked beside the blueprint, written on personal stationery rather than official engineering paper. It contained Ignatov's handwriting, less formal than his technical notes. Bell arrived from East by rail, military escort, structure seamless, composition unknown, appears to be bronze but density calculations suggest otherwise. Extreme resonance when struck lightly with hammer, disallowed further tests per military supervisor. Object to be stored indefinitely. Resonance, seamless, military supervision. These terms began to form a pattern across the sources I had examined. I compared Ignatov's hydraulic cradle dimensions with the substructure beneath the Nikolaevsky Foundry Annex. The sealed corridor mentioned in the 1927 renovation log would have provided exactly the clearance needed to anchor such a cradle's pistons. The circular void detected by ground-penetrating radar matched the platform diameter to within 20 centimeters, well within the tolerance for 19th century construction variation. I returned to the annex site a week later, this time with a structural engineer I trusted. We gained access to the basement level through the Municipal Restoration Office. Though we could not breach the sealed corridor, regulations and preservation concerns prevented that, we could examine the floor above it. The engineer identified stress patterns in the brick vaulting consistent with support pillars that once bore significant weight from below. The spacing of these stress points aligned perfectly with Ignatov's radial piston arrangement. But no record indicates any bell was ever stored at the annex. No inventory, no log entry, no photograph. The silence was conspicuous. I scribbled again in my journal late that night. The annex may not have been built to house metal stock for the foundry, but to receive something older, heavier, and far more refined, something that required hydraulic stabilization and military supervision. Seeking parallels beyond Russia, I expanded my research to international archives accessible through academic networks and digitization projects. But the pattern I found was both broader and more troubling than I had anticipated. In the Ottoman State Archives in Istanbul, a 1901 structural assessment report from architect Halil Erdem describes the discovery of a stone-lined chamber beneath the Bursa clock tower during foundation reinforcement work. The report, written in formal Ottoman Turkish and later translated for me by a colleague, notes, "Circular impressions in the floor stone consistent with the prolonged resting of a massive object, diameter approximately 4 meters, chamber walls polished smooth, origin uncertain, but predates Ottoman construction by estimation of stone weathering." The diameter, 4 meters again. Meanwhile, a French colonial survey from 1893 archived in the National Library of France details a subterranean vault discovered beneath Hanoi's St. Joseph Cathedral during drainage system installation. The vault was lined with granite panels, polished to a mirror finish beyond local capability. The report's author, engineer Claude Beaumont, noted that the granite was not native to the region. Mineral analysis suggested an origin in southern China over 1,000 kilometers away. The vault contained iron clamps and anchoring brackets arranged in a precise circular pattern, suggestive of stabilizing an object whose great mass required distributed anchoring to prevent settling. The measurements indicated a diameter of 4.05 meters. In the British Library's India Office records, an 1889 engineering journal from the port of Madras contains a customs notation describing the transfer of an anomalously large bronze bell weighing an estimated 95 tons through the harbour. The bell was presumed to have originated from a ruined temple complex to the far north, beyond cartographic certainty, a phrase that suggested either Tibet or Central Asia. The journal noted that special reinforced wagons had to be constructed for overland transport, and that the bell bore no visible inscription, decoration, or foundry mark of any kind. I plotted every vault, cradle location, and bell sighting I had documented on a world map, using precise coordinates where available and estimated positions where they weren't. The pattern that emerged was unsettling. The sites formed a lattice, not random, but geometrically spaced, with eerie consistency. The characteristics shared across continents were too specific to be coincidental. Circular vaults or platforms, uniformly 4.0 to 4.2 meters in diameter, hydraulic systems or precisely engineered stone pressure distribution, transport records that mentioned great weight but lacked clear origin points, repeated mentions of old bells, ancient resonant objects, or artifacts of unknown provenance. Subsequent sealing, removal, or destruction of the infrastructure. None of these patterns corresponded to known colonial trade routes, industrial manufacturing centers, or religious bell-casting traditions. The vaults predated many of the structures built above them. The bells, when mentioned, were always described as already ancient. One French military engineer, Louis Delon, wrote in an 1894 letter preserved in the French Army's historical archives, "The bell bears no foundry mark, no indication of origin. Chemical analysis of surface material proves inconclusive. It seems older than the citadel itself, perhaps older than the city." The global pattern was unmistakable but disturbing in its implications. If these were bells, they were not manufactured locally in their respective regions, they were not recently made, and they were not produced with technologies documented in any known 19th century industrial process. I ended this section of my research with one restrained observation written carefully in my journal. Patterns appearing across 3 continents in regions with no cultural or commercial connection suggest a common source older than the 19th century, one whose infrastructure left quiet traces beneath modern cities, traces we have been building over without understanding what they once supported. Historical omission, what archivists call negative evidence, often reveals more than the presence of documentation. While reviewing the 1911 Imperial Inventory of Industrial Equipment, a comprehensive survey mandated by the Ministry of Trade, I noticed a striking absence. No large bells over 3 meters in diameter were listed anywhere in the Russian Empire. Yet earlier correspondence, shipping manifests and photographs from the 1880s and 1890s definitively prove their existence and transport. The St. Petersburg Metallurgical Register of 1890, normally exhaustive in its cataloguing of bronze objects due to their military applications and metal value, lists one bell exceeding estimated 90 tons in weight transported via the Neva River in September of that year. But its destination is marked only with a horizontal line, dash, the administrative equivalent of a shuttered window, a void where information should exist. I checked the margins of the page for annotations, water damage, or any physical reason for the omission. The paper showed no signs of damage. The dash was intentional. The Warsaw freight logs from 1888, preserved in the Central Archive of Historical Records in Warsaw, include a shipping manifest with a code number, TK47B, that corresponds to cargo described in a separate customs document as one large bronze object, ceremonial. But in the freight log itself, someone has scratched out the destination so thoroughly that only the indentation in the paper remains. Scratching was done with force, repeatedly, ensuring complete illegibility. Century corresponds chronologically and geographically with the bell referenced in Tretyakov's 1887 article. In Moscow's Kamovniki district, in a building that once served as an imperial arsenal and now functions as a municipal administrative office, I found renovation documents from 1934 that mention removing obsolete load-bearing hydraulic elements beneath subfloor, purpose unknown. The work order, signed by a Soviet construction supervisor named Petrov, includes a marginal note in different handwriting. Workers report hollow space beneath rang faintly when struck with hammer during demolition, ordered immediate concrete fill for structural stability. The phrase stopped me cold, rang faintly when struck. I obtained permission to visit the site, now housing bureaucratic offices processing municipal permits. The basement had been converted to file storage. The floor was concrete, poured sometime in the mid-20th century based on its composition, but the space retained architectural anomalies. Support columns were spaced wider than Soviet-era construction standards required, approximately 6 meters apart rather than the typical 4. A faint semicircular impression in the floor, barely perceptible beneath layers of linoleum and industrial tile, was visible in certain lighting conditions. When I traced the impression's curvature with a flexible measuring tape, it described an arc whose full circle would measure 415 meters in diameter. Someone had removed the object that once sat there, not recently, decades ago, possibly during the 1930s renovations, when so much pre-revolutionary infrastructure was demolished or repurposed. But the removal was deliberate and thorough. Why? Why transport these objects across vast distances, install elaborate hydraulic systems to support them, and then erase every record of their origin, purpose, and final disposition? I reviewed newspaper archives from St. Petersburg, Moscow, and Warsaw covering the 1880s through the 1930s. I searched for any mention of large bells, unusual bronze objects, or mysterious artifacts. I found scattered references in local papers, curiosities noted briefly then never mentioned again. A bell of unusual size displayed temporarily in a museum courtyard in 1891, an ancient resonant object referenced in a 1903 academic journal, with the article itself missing from bound volumes. A 1912 photograph of workers standing beside metalwork of unknown origin, scheduled for relocation to secure storage, with no follow-up documentation indicating where that storage might be. The pattern of omission was as consistent as the pattern of physical evidence. As I documented more sites, I found more gaps, more dashes, more scratched-out entries, more vague references to removal and secure storage with no destinations specified. I wrote a final note for this phase of my investigation. Evidence does not vanish by accident. Documentation does not disappear through mere neglect. Something about these bells, or whatever they truly were, demanded silence. Someone or some institution wanted them forgotten. The bells shared one unusual property that appeared consistently across every technical document that mentioned them: resonance. But not ordinary resonance, excessive, prolonged, almost unnatural acoustic behavior that seemed to trouble everyone who encountered it. Tretyakov, in his 1887 article, had written, "Light tap with steel hammer produces excessive vibration, felt through floor at distance of 4 meters. Tone continues for estimated 40 seconds, unusually long for object of this mass." Ignatov, in his 1879 journal entry, noted, "Extreme resonance when struck, disallowed further acoustic tests per military supervisor. Workers report sensation of vibration in chest cavity from distance of 15 meters. The Ottoman report from 1901 observed tone persisted unnaturally long after striking. Several workers complained of nausea. Recommended object be removed from occupied structure." I began to analyze the acoustic physics implied by these descriptions. Typical cast bronze bells rely on internal imperfections, microscopic voids, slight variations in thickness, crystalline irregularities in the metal to create complex harmonic overtones that give bells their characteristic rich, textured sound. These imperfections also dampen vibration relatively quickly. A well-made church bell might ring for 10-15 seconds after being struck, but the sound decays steadily. A perfectly smooth, seamless bell of the size described, 4 meters in diameter, likely 8-10 centimeters thick, if structurally sound, weighing 90-110 tons, would behave very differently. Without internal imperfections to scatter and dampen the acoustic energy, such a bell would produce an extraordinarily pure tone at its fundamental frequency. The vibration would persist far longer than normal, and at that scale the acoustic power would be immense. I consulted with an acoustics professor at the St. Petersburg Conservatory. After I described the theoretical properties, seamless bronze, perfect symmetry, massive size, she looked troubled. "An object like that wouldn't function as a musical instrument," she said. "It would be more like an acoustic resonator or amplifier. The tonal purity would be overwhelming. If struck with any force, the acoustic pressure alone could be dangerous at close range, and the vibration—" She paused. "The vibration would propagate through any structure supporting it, through stone certainly, through earth possibly. At the annex, during one of my late-night visits when the building was empty and the surrounding streets quiet, I pressed my ear against the sealed granite arch. For several minutes, I heard nothing but my own breathing and distant traffic. Then faintly, so faintly I couldn't be certain it wasn't imagination or environmental noise, I felt a hum, not audible, not exactly, but a vibration transmitted through the stone, a frequency just below the threshold of hearing but perceptible in my skull, in my jaw. I pulled back and checked for nearby sources, subway vibrations, truck traffic, building HVAC systems. None were active at that hour. The sensation persisted for perhaps 20 seconds, then faded. A 1905 German engineering pamphlet, which I obtained through interlibrary loan, described experiments conducted on an ancient, resonant object seized in the Eastern Territories during military operations. The pamphlet warned that preliminary tests produced harmonic effects that destabilized nearby masonry, causing mortar cracking in load-bearing walls and detachment of plaster from ceiling surfaces. The experiments were discontinued. The object's disposition was not recorded. Did these bells serve musical functions, architectural purposes, mechanical applications we no longer understand? The evidence remained inconclusive, but resonance appeared fundamental to their nature and problematic for any structure housing them. I wrote quietly in my notes that night. These objects may not have been bells in the conventional musical sense, but precision resonant structures, acoustic machines of unknown purpose, built with tolerances that suggest deliberate engineering rather than artistic casting. Across all documented sites, St. Petersburg, Warsaw, Hanoi, Bursa, Madras, one architectural feature appeared with remarkable consistency: sophisticated hydraulic reinforcement. Not simple, but engineered with precision that seemed anachronistic for the 1870s, 1890s period when these structures were supposedly built or modified. Beneath the Nikolaevsky Foundry Annex, Ignatov's 1879 blueprints showed a 12-piston hydraulic cradle with individual pressure regulation. Beneath the Bursa clock tower, the 1901 Ottoman report mentioned underground water channels serving unknown purpose, arranged in radial pattern. Beneath Hanoi's cathedral vault, the 1893 French survey noted evidence of hydraulic pressure distribution system, T function unclear. Hydraulic systems existed in the 1870s, that wasn't in question. The Suez Canal used hydraulic gates. London's Tower Bridge, completed in 1894, employed hydraulic machinery for raising the roadway, but those were massive public works projects with substantial engineering teams and documentation. The precision and sophistication of the systems associated with these bells exceeded anything in contemporary public engineering. The pressure tolerances described in Ignatov's notes, maintaining stability under 110-ton loads while dampening vibration, would have required metallurgy beyond standard capabilities of the era. The pressure vessels and pistons would need to withstand sustained loads without deformation or failure, using seals and valves that wouldn't exist in reliable form until the early 20th century. One detail from the Bursa excavation particularly troubled me. A sketch included in the Ottoman report showed a network of stone-lined conduits radiating outward from the central circular vault, 8 channels, each approximately 30 centimeters in diameter, extending at least 15 meters before the excavation ended. The diagram resembled nothing so much as a hydraulic damping system or an early seismic isolation method, technology that wouldn't be formally developed until the 1970s for protecting buildings from earthquake damage. The stated purpose of these conduits? Unknown, possibly drainage. But the channels sloped incorrectly for drainage, and some appeared to connect to sealed stone chambers rather than leading to outlets. The annex's sealed corridor, according to ground-penetrating radar readings I finally obtained through a university research project, connected to a radial pattern of stone channels beneath the floor. The channels were approximately 40 centimeters square, lined with cut stone, and extended in 6 directions from the central circular void. The pattern was identical in concept to the Bursa system, different in scale and detail, but unmistakably similar in design philosophy. What kind of bell or machine required such elaborate stabilization? Why did builders in Russia, the Ottoman Empire, and French Indochina independently create similar hydraulic infrastructure for objects that were supposedly just cast bronze bells. The consistency was impossible to dismiss as coincidence. These were not local solutions invented independently. They represented a common engineering approach applied systematically across vast distances in an era before international engineering standardization, before professional conferences shared best practices, before technical journals circulated globally. Either there was coordination we have no record of, which seems unlikely given the political and cultural barriers between these empires, or all of these structures were adapting or copying an older template, a hydraulic signature inherited from an earlier period. I wrote one clear observation at the close of this section. The bells were not passive artifacts placed on simple pedestals. They were components requiring advanced stabilization systems, precision mounting, and vibration control. This implies they served an active function, mechanical, acoustic, or otherwise, and that their builders understood principles of pressure distribution, resonance dampening, and structural isolation that were supposedly unknown until the 20th century. In each city I investigated, the sealed sublevels beneath the bell platforms shared one troubling commonality: smooth, featureless walls, not roughly finished stone with visible tool marks, but surfaces polished or finished to a degree unusual for underground construction in any era, let alone the 19th century. The Bursa chamber, according to the 1901 Ottoman report, had walls polished like marble, though material is limestone. No evidence of chisel work or abrasive finishing. Surface appears almost glazed. The Hanoi Vault's granite panels, per the 1893 French survey, showed no tool marks whatsoever. Surface smoothness comparable to modern machined stone. Origin of panels uncertain, not locally quarried. The annex's sealed corridor, glimpsed only in the terse 1927 renovation log and never properly documented, was described as having smooth walls, no fittings, no visible purpose. Underground chambers in the 19th century were utilitarian spaces. Basements, storage vaults, tunnel sections, all showed the marks of their construction. Pick marks in excavated earth, chisel marks in cut stone, rough brickwork in supporting walls. The technology and economic incentive to create perfectly smooth underground surfaces simply didn't exist for structures meant only for storage or support functions. One French engineer, reviewing the Hanoi Vault in 1897 after the initial survey, speculated in a letter to his supervisor that the granite panels were reused from a much older ruin, possibly from the pre-colonial period or earlier. The letter, preserved in colonial administrative files, notes that his colleagues dismissed the idea as fanciful, given the lack of sophisticated stoneworking traditions in the region's documented history. The theory was quietly removed from later official reports, but the engineer's observation remained valid. If the panels weren't reused from somewhere else, then where did they come from? And why install such refined stonework in an underground vault no one would see? In Warsaw, during the demolition of a 19th century warehouse in 1912, construction workers uncovered an underground ring structure, a circular wall approximately 4 meters in interior diameter, descending 3 meters below the building's foundation. One worker, whose personal notebook was donated to a local historical society decades later, wrote, "Stone cold to the touch even in summer heat, hums faintly when struck with iron bar. Foreman ordered immediate fill with rubble and concrete. Work completed same day." Hums faintly. The phrase appeared again in yet another context, in yet another city. These sublevels suggested purpose-built infrastructure, not repurposed cellars or makeshift storage, but platforms specifically designed and constructed to hold large resonant objects in precise positions. The smooth walls might have served acoustic functions, reflecting or channeling sound, or they might have been structural. Materials chosen for their density, their vibration-dampening properties, their durability, under sustained acoustic pressure. By now, I had accepted a quietly unsettling truth that I could no longer rationalize away. The annex's granite foundations were not 1884 constructions built from quarried stone. They were adaptations of something older, something already present when Sokolov drew his plans. He had built around the existing stone, incorporating it into his structure, perhaps not even understanding its original purpose. And if that was true in St. Petersburg, it was likely true in Bursa, in Hanoi, in Warsaw, in Madras. These 19th-century structures were built atop older infrastructure, platforms that predated them by decades, possibly by centuries. I closed this section with one understated question, written carefully in my journal. If these chambers were meant merely to hold bells for storage, why build them with such precision? Why polish the walls? Why create spaces that hum faintly when struck? And who built these chambers before the 19th-century structures appeared above them? Renovation records from multiple cities, spanning the late 19th through mid-20th centuries, consistently reported the removal of components labeled obsolete machinery, outdated fittings, or equipment of uncertain origin. But these components had no documented installation dates, no manufacturer's marks, no entries in original construction records. In Moscow's Kamovniki district, workers in 1934 removed iron brackets and mounting plates from the basement of the former arsenal. Their foreman's report noted that brackets could not be identified against any standard pattern, metal composition unusual, possibly early steel alloy, removed as potential safety hazard. In Bursa, a 1907 municipal maintenance report mentions mechanical remnants, purpose unclear, found during repairs to the clock tower's foundation. The report includes a sketch of iron clamps arranged in a circular pattern with adjustment screws suggesting they once held something in precise position. The clamps were removed and reportedly sent to a museum, though no museum records confirm their arrival. In St. Petersburg, the 1927 renovation log that first alerted me to the sealed corridor notes that the space was empty when discovered. But the description of smooth walls and no fittings actually implies the opposite, implies that something had been carefully removed, leaving behind only the prepared space it once occupied. When I compared bracket spacing, bolt patterns, and radial arrangements visible in the various sketches and photographs I had collected, the alignments suggested a standardized mounting system. Not identical, but related, variations on a common design adapted to local materials and specific site conditions. The brackets, where they appeared in documentation, were arranged in groups of 8, 10, or 12, distributed evenly around a circle. This suggested a frame designed to hold a cylindrical object while allowing for thermal expansion, vibrational movement, and precise leveling, exactly what you would need for a large, heavy, resonant bell. But why remove all the machinery? Why take such care to extract the mounting systems, fill the chambers, seal the entrances? A 1912 engineering manual from Warsaw, published by the Imperial Technical Institute, included an unusual warning in its section on working in older buildings. Exercise caution when demolishing structures near ancient hollow spaces or underground chambers of unknown origin. Mechanical resonance hazards may be present. Avoid striking metal components that ring when tapped. The warning was vague. Deliberately vague, I suspected. The manual offered no explanation of what mechanical resonance hazards might mean, no examples of incidents, no technical details. Just a caution, buried in a section most readers would skip. The omission felt intentional, as though the manual's authors knew enough to warn workers but not enough or were not permitted to explain why. During my months of research, I interviewed 3 retired structural engineers who had worked on renovations of pre-revolutionary buildings in Russia. 2 recalled finding old ironwork that didn't match any construction standards they knew. One specifically remembered a circular mounting frame discovered beneath a building in Tver, removed in the 1960s. "Very heavy," he said. "Precision casting, better than Soviet manufacture. We were told to cut it up for scrap, but the metal was hard. Took diamond blades, never found out what it was for." The infrastructure for these bells was methodically removed over decades, not because it was truly obsolete, but because it was mysterious. Unsettling. Easier to eliminate than to understand. I ended this chapter with a quiet truth I had come to accept. The machinery was removed not because it had failed or outlived its usefulness, but because no one in the 20th century could explain its purpose. Things we cannot explain make us deeply uncomfortable. Removing them, filling the spaces, sealing the chambers. This was easier than confronting the possibility that our cities were built atop infrastructure we did not create and could not replicate. When I finally plotted all documented bell-related sites on a large-scale world map, printing it across 4 connected pages and marking each location with careful precision, the pattern that emerged was more disturbing than I had anticipated. The sites formed a lattice. Not a random scatter, but a geometric distribution with regularities that were difficult to dismiss as coincidence. The distances between sites in St. Petersburg, Warsaw, Bursa, and Hanoi corresponded to ratios I recognized from military architecture, specifically from star forts and bastioned fortification systems developed in the 16th and 17th centuries. The spacing wasn't identical, but the proportional relationships were consistent, primary sites separated by approximately 1,500 and 2,000 kilometers, with secondary sites filling gaps at roughly half that distance. While this observation was not definitive, geography and transportation routes could produce similar spacing patterns without intentional planning. The consistency troubled me. I checked against other distribution patterns: Roman roads, Silk Road caravanserais, medieval monastery networks. None matched as closely. The vaults themselves shared even more specific commonalities: circular platforms or chambers, uniformly 4.0 to 4.2 meters in diameter within about 5% variation, granite, marble, or limestone walls polished beyond documented period capability, hydraulic reinforcement systems or precision stone pressure distribution, circular sublevels with smooth walls, evidence of later sealing, deliberate removal of components, or destruction. Systematic erasure of documentation regarding origin and purpose. The bells, when mentioned in contemporary sources, were described as seamless or nearly seamless in construction, unusually heavy, 9,110 tons consistently estimated, highly resonant with prolonged tones, requiring specialized hydraulic transport cradles, lacking foundry marks, inscriptions, or identifiable origins already ancient when documented in the 19th century. These characteristics did not vary significantly across regions. A bell in St. Petersburg exhibited the same properties as a bell in Hanoi. The vaults in Warsaw resembled the vaults in Bursa. The hydraulic systems in Russia paralleled those in Ottoman territory. This uniformity was impossible to reconcile with the documented historical context. In the 1880s and 1890s, the Russian Empire, Ottoman Empire, French colonial administration, and British India operated independently with minimal technical exchange. There were no international engineering standards, no global conferences, no shared technical journals that circulated widely. An engineer in St. Petersburg would have no knowledge of construction methods in Hanoi. An Ottoman architect would not know what French colonists were building in Vietnam, yet they appeared to be adapting, maintaining, or reconstructing infrastructure that followed a common template, a hydraulic signature that transcended political boundaries and cultural contexts. The implications were uncomfortable. Either there was unprecedented coordination across these empires, for which I found no evidence, or all of these 19th century builders were working with remnants of an earlier system. a network of structures they inherited whose original purpose they may not have fully understood. The bells themselves, always described as ancient even in the 1880s, may have been the last surviving components of this system, artifacts that outlasted the knowledge of how to build or use them. The 19th century engineers encountering these objects did what made sense. They transported them to secure locations, installed them in carefully prepared vaults using the best stabilization technology available, and attempted to preserve them. And then, a few decades later, removed them and erased the records. Why? I wrote cautiously at the end of this section, choosing my words carefully. We may be observing remnants of a lost engineering system whose scale the 19th century could neither fully replicate nor comprehend. A network that once spanned continents, built with precision we would not achieve again until the late 20th century, serving purposes we can only infer from the fragments that remain. In late December 2023, after months of formal requests and persistent negotiation, I gained restricted access to a sealed maintenance alcove beneath the Nikolaevsky Foundry Annex. The access was granted through a municipal restoration contact who owed me a favor from earlier archival work, and it came with strict conditions: 2 hours maximum, no removal of materials, photographic documentation permitted but subject to review. I arrived at dawn. The restoration supervisor unlocked a steel door I had never noticed during my previous visits, set flush into the eastern wall, painted the same grey as the surrounding concrete, effectively invisible unless you knew where to look. The narrow stairs descended 3 meters into darkness. The space beyond was small, perhaps 4 meters square, and dusty with the peculiar stillness of long sealed rooms. The air was cold, noticeably colder than the basement above, and carried a faint mineral smell like wet stone, until I noticed the wall surface. The eastern wall was not concrete, not brick. It was polished granite, smooth as glass. My flashlight beam reflected off it as though from a mirror. I approached slowly, extending my hand, feeling the surface with my fingertips. Cold, unnaturally cold, resonant when tapped gently with my knuckle, not hollow but not solid either. A tone that seemed to travel into the stone rather than reflect back. The floor showed a faint semicircular indentation worn into the concrete, or perhaps preserved beneath it. When I measured it carefully with a tape measure, working by flashlight in the confined space, the curvature described an arc whose full circle would measure 4.18 meters in diameter, exactly consistent with every other measurement I had documented. The air in the chamber felt still, almost expectant. I'm not generally prone to subjective impressions, but standing there in the darkness I felt as though the space was waiting for something to return, as though the absence itself had weight. On the far wall, barely visible beneath layers of old paint and concrete patching, I found a faint ring-shaped discoloration. The mark ran in a perfect circle, about 3 meters in diameter, centered at roughly shoulder height. The discoloration was darker than the surrounding stone, suggesting prolonged contact with metal, oxidation transferred to the granite over years or decades of contact. I photographed it carefully, using oblique lighting to enhance the contrast. In the digital images reviewed later on my computer, a faint line, almost a seam, encircled the discoloration, but the seam appeared to be in the stone itself, not on its surface. As though the stone had been cut, installed around something, then sealed so carefully that the joint was nearly invisible, not carved into the wall, not plastered over. Something had rested here, mounted against this wall, supported from below by the platform whose impression remained in the floor, for long enough to leave a molecular memory in the granite itself. Something resonant, something massive, something precisely engineered, something now missing, removed with such care that even the mounting points had been ground smooth. I spent the remaining time examining every surface, measuring every dimension, photographing every detail. The restoration supervisor knocked on the door at exactly 2 hours, and I reluctantly ascended the stairs, emerged into the December morning light, and walked back to the archive with my camera full of images that raised more questions than they answered. I ended my notes that evening with a final restrained observation. The Nikolevsky Foundry Annex was never merely a building constructed in 1884. It was a receiver, the last documented terminus for something older, heavier, and precisely engineered, built around existing foundations, incorporating granite cut with impossible precision, designed to hold an object whose resonance required hydraulic stabilization and whose origin no one recorded. The annex was not original construction. It was the last adaptation, the final attempt to house something that would be removed a few decades later and erased from historical memory. The question is not whether these objects existed. The photographs and documents prove they did. The question is, what were they? And why did someone want us to forget? In the dim basement of the municipal archive, late on a winter evening with snow falling silently outside, I returned once more to plate 17B. I had examined this photograph dozens of times by now, but I loaded it one final time into the high-resolution scanner, magnifying the background detail to its maximum clarity. The faint curvature behind the stacked timbers, the shape I had noticed months ago during my first investigation, resolved into something clearer at this magnification. An arc, smooth, metallic, impossibly precise. A bell, or something like one. The object no longer exists. Its hydraulic cradle has been dismantled, its sublevels sealed with concrete, its mounting brackets removed and scrapped, its transportation records scratched out of shipping logs, its destination marked with dashes in inventory registers. Only the shadow remains in this photograph, quiet, patient, inexplicable. A geometry that shouldn't exist in 1885, documented accidentally in the background of a construction photograph that was meant to show scaffolding. And sometimes, in the silence of the annex's sealed chamber, when I press my ear against that polished granite wall, in the darkness 3 meters below the street, I think I can still feel the faintest hum. A resonance that persists in the stone itself, an echo of something that once rested there. Something we transported across continents, something we carefully stabilized with hydraulic engineering decades ahead of its time. Something we eventually removed and erased from every official record. Something we were never meant to forget but did,